In this first question, we're asked to use a graph which connects to this data table of molarity change per time. So when we want an average rate over time, we look at the final and initial values. Final minus initial allows us to get this change right here. We have a pretty significant change going from 7 or down to 7 from 148. And then we are obviously going for 60 seconds. As we're looking at this, one thing to pay attention to on this and all questions is the unit you're using for time. It said for the first minute, but since I entered it per second, I would need to report it as molarity per second. The other thing is we would notice that 7 minus 148 would come out to a negative number, but as discussed, rates are always going to be presented as positive. For the instantaneous rate at a certain time, we draw a line tangent to that point in time. Although this probably is far from perfect, you get the idea that hopefully it's passing through that point without dragging along the line too much. So then I looked at where did it cross over here. It was at 120 minus the 0, and then that was around 35. Not exact values, and if we had the equation of this line and some calculus skills, we could get a better value. But for our purposes, this is more than good enough. And we see, even though it was an average of 2, at that moment, only 20 seconds in, it was going faster. We started really steep, and it slowed down over time. The second scenario gives us a balanced equation. Peroxide reacts with iodide and hydrogen to make the I3 minus ion and water, and we see that the iodide is dropping from 1 to 0.868. Find the average rate of reaction. So when we are finding reaction rate, or if we're just thinking of reaction rate, we're thinking of it in terms of the things that have a coefficient of 1. Well, iodide gets consumed 3 times faster than the peroxide, for example, and it gets consumed 1.5 times faster than the hydrogen or than the water is made. So first I think about what is my change. I've got my molarity per second, but then I would divide by that. So divided by the negative 1/3, because that's going away, 1/3 to get to a coefficient of 1, then allows me to see that 0.0044 molarity per second would be the average reaction rate. Sorry, I was checking if it was average. Something a lot more common would be comparing iodide to hydrogen ion, where we're comparing one chemical to another. Since we already have the overall rate, we can look at it like this. But we could also take this number right here, and we're really just doing stoichiometry. Yes, the units on here are molarity per second, but the hydrogen would have a 2 molarity per second on top relative to the 3 molarity per second on the bottom for this. So that number times 2/3 is the exact same value as what we're seeing here. Or we can convert to the reaction rate relative to a coefficient of 1 and then use that to look at any others. So we can do it in a couple ways, but what's really important is the 1/3, the 1/2 are just doing stoichiometry with the coefficients of 2 and 3.